Hello, hi everyone. Welcome to the Story in the Brand. So, hi everyone. Welcome to the Student Brand. This is your Shiva sir. Today topic is light reflection, diffraction. So, welcome to the Student Brand. This is your Shiva sir. Myopia, 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 myopia. Near distance we can see far distance we can see myopia, myopia, myopia. Near distance we can see far distance we can see myopia, myopia, myopia. For that correction we are using, bro, what bro? For that correction we are using concave lens, concave lens, concave lens, concave lens, hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see hypermetropia, hypermetropia. Further correction we are using convex lens, convex lens, convex lens, convex lens, hypermetropia, convex lens, hypermetropia, convex lens, hypermetropia, convex lens, hypermetropia, convex lens. Next one. New Cartesian sino convention, new Cartesian Sign convention, all distance measured from the pole. Distance are positive along the instantaneous, distance are negative opposite to instantaneous, distance are positive along the principal axis, distance are negative opposite to principal axis, distance are positive above the principal axis, distance are negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention, all distance are measured from the pole, distance are positive along the instant trace, distance are negative opposite to instant trace, distance are positive. So we'll go with that. Both the practice session, preparation session. Distance are positive along the instant, distance are negative opposite to instant, distance are positive above the principal axis, distance are negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. Okay, so that's enough. So welcome to the class. So we'll discuss about okay, fine. So we'll discuss the practice session along with the explanation. Practice session, little more depth related to concepts, related to points. Everything we'll discuss. Everything we'll discuss now. So we will see how best we can go with that explanation and revision part. So we'll see now. We can go with that light reflection or diffraction chapter. Light reflection and refraction, light light reflection and diffraction, light reflection and diffraction I'm taking. So light reflection and diffraction, light reflection and refraction. So CBSE Grade-10 physics, CBSE Grade-10 physics. Okay, so first one, light is a form of energy. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. See, you can observe when light falls on a particular material, so particular material reflect back. It reflect back. After reflection only we can able to see the light rays. After reflection only we can able to see the light rays, right? So if the light ray incident on it, then only it will rebounce. Okay, so the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Or simply we can say the light is when the light is coming from one okay, when light is incidentting on the surface, it reflects back into the same medium. It reflects back into the same medium. So that is called reflection of light. So now I am considering here. This is a plane surface. Plane surface, plane surface, plane surface, 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 plane surface, plane surface, plane surface. The light ray incidentting on the surface, on the plane mirror. Light ray is incidentting on the plane mirror. So the mirror is called reflector here. Why we are saying mirror is a reflector? Why we are saying mirror is a reflector? Because the mirror is reflecting the light. The mirror is reflecting the light. That's why it is called reflector. That's why it is called reflector. That's why it is called reflector. When the light incident on the surface, it reflects back into the same medium. That reflect back into the same medium. It reflects back into the same medium. The bouncing back of the light from the reflecting surface is called reflection of light. Okay. So incident ray, reflected ray. So I'm taking this the incident ray, and I'm considering this is the reflected ray, reflected ray, reflected ray. The line which is perpendicular to the surface, that is called normal line. So the angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected and deviated line is called angle of deviation. Angle of deviation. So you can observe here, angle between incident ray and normal line is called angle of incidence. So angle between reflected and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. Angle of deviation. Okay, angle of deviation. Angle of deviation. So angle between incident ray and reflected ray, angle between incident ray, reflected ray, angle between incident ray, reflected ray, angle of incident, angle between reflected ray and normal line is called angle of reflection, angle between reflected and normal line is called angle of reflection, angle between reflected and undeviated line is called angle of deviation, angle between reflected and undeviated line is called angle of deviation. So here we can take the linear angle. I'm taking. What is the linear angle? The linear angle is 180 degrees. Linear angle is 180 degrees. Okay, so linear angle is 180 I'm taking. Linear angle is 180, right? Linear angle is 180. 180 degrees. 180 degrees. So that is nothing but angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So here one point you need to understand one thing. So here we can go with the laws of reflection. We have to go with the laws of reflection. Angle of incidence equal to angle of reflection, like laws of reflection. Coming to laws of reflection, laws of reflection, laws of reflection, laws of reflection, laws reflection, laws of reflection, laws of reflection, laws. So first point is incident ray, reflected ray, normal line, it lies in the same plane. The second one, if you are taking angle of incident is equal to angle of reflection. So incident ray, reflected ray, normal line lies on the same plane. Angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. These two are the laws of reflection. From taking these two laws of reflection, from taking these two laws of reflection, so from this condition, if you are taking this formula, okay, angle of incidence plus angle of deviation equal to 180 degrees. 180 degrees. So in the place of angle of reflection, I am substituting angle of incidence. In the place of angle of reflection, I am substituting angle of incidence. So 2 angle of incidence plus the angle of deviation equal to 180 degrees. So angle of deviation equal to 180 degrees minus 2 angle of incidence. 180 degrees minus 2 angle of incidence. Understood? So once again, this is the incident ray, reflected ray, normal line, incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. So the linear angle is 180 degrees. The linear angle is 180 degrees. The linear angle is 180 degrees. Linear angle is 180 degrees. So from laws of reflection, incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So incident ray, reflected ray, normal lies on the same plane. Angle of incident is equal to angle of reflection. Okay, so from that, so if you are taking this one, angle of incident plus angle of reflection plus angle of deviation. So this total angle is 180 degrees. This total angle is 180 degrees. This total angle is 180 degrees. Total angle is 180 degrees. So that's why angle of incident plus angle of reflection plus angle of deviation equal to 180. So in the place of angle of reflection, from loss of reflection, I am substituting angle of incident. So angle of incident plus angle of incident plus angle of deviation equal to 180 degrees. So 2 angle of incident plus angle of deviation equal to 180 degrees. Angle of deviation equal to, oh my god, angle of deviation equal to so 2 angle of incident plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of incidence. So listen here, very very important point. Underline this point, and one more point we can say. Angle of deviation equal to 180 minus 2 angle of reflection. Angle of deviation equal to, angle of deviation equal to, everybody say with me, angle of deviation equal to 180 minus 2 angle of reflection. 2 angle of reflection. So again repeat with me, angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. So according to the substitution, how you are considering angle of incident, angle of reflection, based on that you will get angle of deviation. Angle of deviation formula is 180 minus 2 angle of incidence. And in another way also we can write that what we are saying, that is what we are saying, angle of deviation equal to, angle of deviation equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. Angle of deviation equal to 180 minus 2 angle of reflection. 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 What is a reflection? The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Reflection of light. Bouncing back of the light from the reflecting surface is called reflection of light. Okay, so next one we are going to the next topic. So there are two types of reflection: regular reflection, irregular reflection. Oh my god, what is regular reflection? What is irregular reflection? How they will ask in the exam? We will discuss now. There are two types of reflections are there. So let's we start. Sir, you should take rest. You need now have to wear attire the clown and sing your knowledge. It is enough. Bouncing back of the light from the reflecting surface is called a reflection of light. Bouncing back of the light from the reflecting surface is called a reflection of light. Laws of reflection. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Are you listening or not? Laws of reflection. Define laws of reflection. So define laws of reflection. Define laws of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Define loss of reflection. So everybody define loss of reflection. Define loss of define loss of reflection. Define loss of reflection. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident equal to angle of reflection. Define reflection. The bouncing back of the light from the reflecting surface is called the bouncing back of the light from the reflecting surface is called the bouncing back of the light from the reflecting surface is called reflection of light. So is it angle of incident is equal to angle of reflection? Yes, angle of incident equal to angle of reflection. What is angle of deviation formula? So angle of deviation formula is 180 minus 2 angle of incidence. Angle of deviation formula is 180 minus 2 angle of reflection. Okay. So what is angle of deviation? The angle between reflected ray and undeviated line is called angle of deviation. What is angle of incidence? Angle between incident ray and normal line is called angle of incidence. Okay. Next one. What are the types of reflection? Regular reflection, irregular reflection, regular reflection, irregular reflection. If the light passes along the normal line, so what is angle of incident and angle of reflection? If the light passes along the normal line, angle of incident is 0, angle of reflection is 0. What about angle of deviation? If the light passes along the normal line, if the light passes along the normal line, so if the light passes along the normal line, angle of incidence is 0, angle of reflection is 0, angle of deviation is 180 degree. Okay, so one more question, last and final question. So we'll discuss here. Define reflection of light. Define reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Reflection of light. Okay then. So can you explain types of reflection? Of course, we will discuss types of reflection. Types of reflection. Types of reflection. There are two types of reflection. There are two types of reflection. There are two types of reflection. Two types of reflection. One is regular reflection. Types of reflection. Types of reflection. Types of reflection. Point number one is regular reflection. Regular reflection. Regular reflection. Second one is irregular reflection. Irregular reflection. Irregular reflection. So coming to regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. I am taking the plane mirror like this. So plane mirror, light is incidenting on it. If the incident beam is parallel, in regular reflection, if the incident beam is parallel, reflector light rays also parallel to each other. In regular reflection, incident light rays are parallel, reflector light rays also parallel to each other. So I am taking incident light ray. So the reflector light rays also parallel to each other. Reflector light rays also parallel to each other. This type of reflection is called regular reflection. Coming to irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface, incident ray, incident ray, incident ray, incident ray, reflected ray, reflected ray, reflected ray, reflected ray, reflected ray. Okay, so this is about irregular reflection, right? Irregular reflection. Irregular reflection takes place on rough surface. Regular reflection, can you tell me regular reflection example where regular reflection takes place? Regular reflection takes place on plane mirror. Regular reflection takes place on plane mirror and still water. Okay, so where irregular reflection takes place? Irregular reflection takes place on wall, on book, on cardboard. So and cinema screen, on cinema screen, cardboard, book. These are the irregular reflections. Irregular reflections. Okay, okay, okay. So now we are going to the next one. Object and image. Okay, here one more point I will ask. Under what conditions? Under what conditions incident ray, reflected ray becomes normal or parallel to each other? Incident ray and reflected light ray parallel to each other. So we are arranging the two plane mirrors. So incident ray and reflected ray always parallel to each other. So under what conditions? So I will tell that also. It's very easy. Very easy. That is, so I'm telling now. So if the light pair, if the plane mirrors arranged in perpendicular to each other, if the plane mirrors are arranged in perpendicular to each other, so like this, if you are taking incident ray, so these two are plane mirrors, so placed perpendicular to each other means makes 90 degrees, makes 90 degrees. So one is incident ray, so I'm taking this incident ray, so reflected ray, and this one is the, so again reflected ray. So these two becomes parallel. So I'm taking this normal, this also normal. So angle of incidence, angle of reflection, angle of incidence, angle of reflection. Under what conditions, under what conditions, under what conditions, under what conditions, incident ray, reflected ray always be parallel to each other? Under what conditions? So how you will arrange two plane mirrors in such a way that incident ray, reflected ray will be always, so incident ray, reflected ray will be always parallel to each other. Only this case, when if the two plane mirrors arrange, the two plane mirrors arrange in such a way that so both are perpendicular to each other, makes 90 degrees, makes 90 degrees, then incident ray, reflected ray both will become parallel to each other, both will become parallel to each other. Next one we are going to that. So object and image, object and image, object and image. So till now whatever I explained, in that I will ask few questions. I'll ask few questions. So if you know the answer, you can tell me. First question, what is the reflection of light? The bouncing back of the light from the reflecting surface is called reflection of light. So the bouncing back of the light from the reflecting surface is called reflection of light. Okay, so what is the angle what is the angle of glancing angle of incidence? So here is very important, glancing angle of incidence. So I'm taking here, so this is incident ray and this will be the reflected ray and this will be the normal line. So I'm considering like this. The angle between incident ray and plane surface is called glancing angle of incidence. Angle between incident and plane surface. And glancing means glancing angle. Glancing angle means, so what are the light ray incident, that light ray makes with the mirror. So that line will make some angle with the mirror. Now, normally we know angle between incident ray and normal line is called angle of incident. Angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. What about this angle? What about this angle? So there also angle is there, right? There also angle is there, right? So actually it is there. So indirectly, see, 1 or 2 points in depth, additional points they will give. Additional points are given. So generally they didn't ask, rarely they didn't ask. Till now, we don't have any discussion about glancing angle. But if you know those points, it will be helpful. It will be helpful. You can check in internet also. You can check in Google also. Same points will be getting. Okay. So it's not out of the box. It's not about okay, where are so new things? It's not my invention also. So whatever things are there, we are studying and okay, we are explaining. That's enough. So angle between incident ray and plane surface is called glancing. See, incident ray and plane surface. Incident ray and plane surface is called glancing angle of incident. Incident ray and reflected ray and plane surface is called glancing angle of reflection. See, you should know the additional points. So I'm not saying ignore the points. I'm saying so keep it as a backup. Keep it as a backup. Okay, backup in the sense where even the paper is very difficult, extreme conditions where the CBSE board will go unactivated areas in the sense. So in the concept itself, in that concept also, if you know in depth, definitely you will succeed. You will succeed in the sense you will get good marks, you will write well, so you will satisfy. Content is the key. Even in the movies, what is main? Content. Even teaching, content. Okay, so even if you want to speak over 1 hour, 2 hours, what is required? Content is required. So if you speak something same again and again, if you are repeating, if content is not there, no one will listen, right? Content is the key. So with the content, if you do anything, so definitely, so it will be a huge hit. Okay, so come to the point. So the angle between incident and plane surface is called angle of incidence. Angle between reflected and plane surface is glancing angle of reflection. Okay, sometimes they will ask this question. Normally they will ask this one. Okay, so normally they will ask how much angle the incident ray will make with the surface. So they will ask in this way. They won't maybe the term they won't mention maybe. Okay, so till now they didn't mention, but they will mention in that way. They will mention in such a way that what is the angle. So if the angle of incident is suppose 30 degrees, angle of incident is 30 degrees. What is the angle? What is the incident? How much angle the incident ray makes with the surface? Incident ray makes with the surface. Like this also they will ask. The way of asking is different. Maybe terminology they may not use, but definitely the asking questions will be in this format. Like so the angle between incident and normal line is called angle of incident is 30 degrees. So what is how much angle the incident ray makes with the surface? Incident ray here very clear. Be particular about the term. Incident ray with the surface. Incident ray with the surface or with mirror also means. So here I took the plane mirror, that's why I'm saying a plane mirror. But if you take another surface like any other medium, any other surface, so the angle between incident and plane surface, right? That also like that they will ask. They may not use the word glancing angle, but they will ask this way they can ask. CBSE, so they these questions they asked also. So like this format. The way of asking, definitely this format they will ask. So the format is what is the angle between incident and plane surface? What is the angle between incident and plane surface? If the angle of incident is 30 degrees, angle of incident is 40 degrees, angle of incident is 60 degrees, or sometimes very important, I will tell. So one of the questions they ask like this also. So angle of reflection is 60 degrees. Suppose I am taking angle of reflection is 60 degrees. So I am taking like this. So if you are taking here angle of reflection means angle between reflected and normal line. Angle between reflected and normal line, angle of reflection is 60 degrees. Okay, done. So what is the angle the incident ray makes? How much angle the incident ray makes with the surface? How can we find out? So answer is, so we know angle of incident equal to angle of reflection from loss of reflection. So this also 60 degrees and this angle is 30 degrees because this angle is 90 degrees. Yes or no? So the angle between, so this total is 90. This angle is 60. 60, 90 minus 60 is 30 degrees. Like that also we can find out. Like that also we can find out. Yes or no? Yes or no? Okay. So the way of asking questions, definitely the way may change, but concept you have to learn. Concept you have to learn. There is no other choice. Concept you should learn at any cost. So concept you should learn. That is very important. Okay. So now we are going to the next one. So and one more thing, one more question also I asked in the previous class. Okay, when the light ray passes along the normal line, what is the angle of incident and what is the angle of reflection? And what is the angle of deviation also? Angle of deviation also they asked. And one more question also they will ask. Okay, so they will give the diagram. Sometimes they will give diagram like this. They will give the diagram like this. This the two plane mirrors. Okay, and one question they given some, I hope. So this they will give like this. So to this only, this angle is 60 degrees. Okay, 60 degrees. How much angle the reflected ray makes? What is the angle of reflection? So sorry, what is the angle of reflection? What is the angle of reflection? Can you find out the angle of reflection? Where the light ray is leaving from the mirror? This the angle they asked. Sometimes they will give diagram like this. Can you identify how much angle it is? This angle, can you identify this angle I want? This angle I want. Anyone can tell this angle? So how much angle is here? Angle between reflected and normal. Anyone can tell this angle? Very easy. Very easy. If you know triangle rule. Triangle is sum of the angles in triangle how much? 180 degrees. Sum of the angles in triangle is 180 degrees. If you know this small logic, we can identify this angle. We can get to know this angle. How can you tell me how it is possible? Sir, how to find out this angle here? So you give an angle of incidence 60 degrees. So sometimes they will give this type of diagrammatic questions. That time, how to find out this angle? Can you tell me? So I will tell. Easy way. Some of the we know one rule. What is some of the angles in trigonometry from trigonometry. So trigonometry is very excellent chapter. Try to learn it because in physics major questions related to integration, trigonometry, derivatives. Okay, maths. So in coming classes you'll get. Okay, so you can learn. Now we can see. So the angle of incident equal to angle of reflection is 60 degrees. So normally if you are taking what is this angle 90 degrees, total angle 90 degrees. This angle is 90, then it automatically is 30. Here anyway this is perpendicular angle 90 degrees. 90 plus 30 how much? 120. 180 minus 120 how much? 60 degrees. Here is 60 and here is 30 and this is 30. How it is? Excellent, no? If you like it, do a like. At least. If you like this explanation, do a like. That's enough. I'll explain once again. Okay, listen carefully here. So they given this angle. Okay. This angle is given. We need to find out this angle. How to find out? Here you can see angle of incident is 60 degrees. So angle of reflection also 60 degrees. Angle of incident 60, angle of reflection also 60. So this it makes 90 degrees. From here to here 90 degrees. So 60 plus 30 is 90. So here remaining is 30. Already here 90, right? The two plane mirrors are placed 90 degrees. Okay. So these two are, so the angle between this one is 90 degrees. So this 30 plus 90, how much? 120. So 180 minus 120, 60. Here 60. So then this is 90. Total is 90, right? Now normal line and plane surface. So here 60, here 30. So 90. Here anyway angle of incident 30, angle of reflection also 30. That's enough. Yes or no? Simple. Very easy. Nothing else. No, simple logic is you need to understand. You need to understand how to identify the angle. So which angle it is? Okay, so you have to take it. Okay, angle of, so you have to consider how much is there is a triangle. Then angle of incident. Here I use the minimum two rules, only two rules. Point number one is sum of the angles in triangle is 180 degrees. Okay, three rules came. Okay, next one is angle of incident is equal to angle of reflection. Third rule is so perpendicular line, perpendicular angle is 90 degrees. So if you know these three rules, we can solve this problem. Sum of the angles in triangle, sum of the angles in triangle 180. Point number one. So angle of incident equal to angle of reflection. Point number two. Point number three. Point number three. So point number three, this only, right? So we'd apply here 90 degrees. Here also 90 degrees. Anyway, this is 90. We know it. We know it. Okay. So that's why I'm telling. That's why I'm telling. So in any related to diagrammatic questions, you can apply these rules. These 3 points you can apply. You can check, verify. So whether you are getting answer or not, that's a different matter. You must follow the process. You must follow the process. If you follow the process, you will get it. If you follow the process, you will get it. Understood or not? So 180 degrees, sum of the angles in triangle is 180 degrees. Angle of incident equal to angle of reflection. And 90 degrees. So perpendicular angle is 90 degrees. Yes or no? That's enough. Simple way to identify is follow this format. Okay. Follow the rules and regulations. Follow the rules and regulations. Definitely will get it. Okay. So next one we are going to the next form. One more question I'll give. Try this question. One more question I'll give. Try this question. Okay. So will you try? So related to mirrors, this question only. Angle of incident, angle of reflection. So related to that one, I'll ask one question. Final. So tell me that regular reflection. Where regular reflection takes place? Example. Can anybody say regular reflection takes place? Question number one. Regular reflection. Where it takes place? Regular reflection. I already explained, right? Regular reflection, where it takes place. So 1 and 2, at least 2 examples. I said 2 examples only. Mirror, very good. Mirror next. So any other place regular reflection takes place. Regular reflection. Plane mirror, okay. And one more example, still water, we can say still water. Water is moving. If it is water is moving, we can't say still water. Constant water, the surface will be regular. So it acts as a regular. Sir, I think so. Okay. I hope it is clear to you. Okay, next one. We are going to the next one. So that's enough. That is about regular. Irregular reflection, where it will takes place. Irregular reflection. Where irregular reflection takes place. Can you know? Let me know where irregular reflection takes place. Irregular reflection takes place on, or we can say wall. Here, one more question is there. One more question I'll ask. One more question. So, mirror reflect the light rays, and wall also reflect the light rays. What is the difference? Mirror reflect the light rays and wall also reflect the light rays. What is the difference? Mirror reflect the light rays and wall also reflect the light rays. What is the difference? Mirror reflect. So regular reflection takes place on mirror. Irregular reflection takes place on wall. Regular reflection takes place on mirror. Irregular reflection takes place on wall. Right? Yes. Next one, we are going to the next one more point. So object and image. We'll discuss about object and image. Object and image. So here I am considering this the object. So here you can observe. Here you can observe. This is the real object. From the object, light rays are coming from the point, and here also coming from this point. After reflection, those light rays will move away. Here also those light rays will move away. So if you are extending this reflector light rays, if reflector light rays are meeting at one point, if reflector light rays are meeting at one point, reflector light rays are meeting at one point. So I'm considering here. So these are the reflector light rays. Here also reflector light rays. So here I'm taking this is a virtual image. Virtual image. Virtual image. Real object and 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 virtual image. Right? And one more thing I am taking here. So this is the light rays are coming from infinity. So something like this. Some point. So after that, light rays are coming from infinity. After reflection, those light rays will meet like this. Okay, those light rays will meet. Okay, so if you are extending these light rays, those light rays will meet at one point. So I am considering here, if the light rays are meeting at one point here, so the image will form here. So this is object, virtual object. This is the real image and virtual object. Real image and virtual object. Here you can observe. So this is the reflector light ray. This is reflector light ray. Reflector light ray. Those reflector light rays are meeting at one point. Those reflector light rays are meeting at one point. Those reflector light rays are meeting at one point. Those reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Here we are extending the incident light rays. If the incident light rays are meeting at one point, that is a virtual object. If the incident light rays are meeting at one point, that is a virtual object. Okay, virtual object, that is virtual object. So here directly reflector light rays are meeting. That's why real image. So now you can observe here in these two cases. If you observe in these two cases, okay. So I'm considering now. You can see. So I'm taking object and image. Object is real. Image is virtual. Object is virtual. Image is real. Once again, object is real. Image is virtual. Object is virtual. Image is real. Vice versa. Virtual object means the point of intersection of extended reflector light rays. So the definitions are very, very important. Definition: the point of intersection of extended reflector light rays is called the point of intersection of extended reflector light rays is called the point of intersection of extended reflector light rays is called the point of intersection of extended reflect light rays is called virtual image. The point of intersection of extended reflector light rays is called virtual image. If the direct reflector light rays are meeting at one point, reflector light rays are meeting at one point, their image will form. That is the real image. So if you are extending this incident rays, incident rays are meeting at one point. That is a virtual object. Extended incident light rays are meeting at one point. That is a virtual object. So reflector light rays are directly meeting. That is a real image. So here extending the reflector light rays. Extended reflector light rays are meeting at one point. That is called virtual image. So if the light rays are coming from the object, light rays are coming from the object, that is a real object, real object. So here you can observe from that from these diagrams we can conclude that object is real, image is virtual. Object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. Okay, so these are the points. Here you can see object is real, image is virtual. Object is virtual, image is real. Virtual object, real image. Real object, virtual object. Okay, so the difference you need to understand. What is a real virtual image? The point of intersection of reflector light rays. 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 The point of intersection of extended reflector light rays. The point of intersection of extended reflector light rays. We are extending this reflector light rays. Here, if the directly reflector light rays meet, that is the real image. Here, virtual image, we are talking about virtual image. The point of intersection of extended reflector light rays are called the point of intersection of extended reflector light rays. The point of intersection of extended reflector light rays is forming virtual image. Directly reflector light rays are meeting real image. Directly reflector light rays are meeting real image. So if you are extending the reflector light rays, that is a virtual image. The point of intersection of incident light rays. From this point light rays are coming. From this point light rays are coming. That is a real object. Here you can see the point of intersection of extended incident rays. This is the extended incident. This is incident ray. Incident ray. We are extending this incident rays. Those incident rays are meeting at one point. Their image is forming. That is a virtual object. That is a virtual object. I hope it is very clear to you all. I hope it is very clear to you all. So is it clear? So you have to take object and image, object and image, object and image, object and image. Okay. So must be clear with this concept. Be clear with this concept. Very, very important concept. Very, very important concept. Next one, we are going to the nature of the image. Nature of the image formed by the plane mirror. Nature of the image. Thank you. Thank you. Thank you, Narsi. 13 country, baby after. I don't know your name. So the user ID Belugu, Belugu like that. So your thought process is nice. Thought process. But we'll see. Okay, done. Come to the point. Come to the point. Come to the point. Okay, so small break. I'll drink water and come. So next I'll explain about nature of the image formed by the plane mirror. So now we are going to discuss. So here, okay, come to the point. So we'll discuss now. I'm taking the plane mirror here. Plane mirror. So here I'm considering. So this is the object. This is the object AB. Light ray is incidenting on it. So it will be reflected like this. So one more light ray is incidenting on it. So it will be reflected. So here you can observe this is a plane mirror. Whatever I am considering plane mirror. Sushma Singh, hi. Ayush, hi. Hello, Ayush. Are you my student? So yes or no? There's something. Sir, sometime. Yeah, yeah, Sushma Singh. Okay, so we are coming to the next point. Coming to the next point here. So if you are taking like this, I'm considering here. So this is the incident ray and this also incident ray like this. I'm taking here. Okay, so this is A dash and B dash. AB is the object, A dash, B dash is the image. AB is the object, A dash and B dash is AB. So AB is the object. AB is the object, A dash, B dash is the image. A dash and B dash is the image. Okay. So now first point is already before only I said object is real, image is virtual. 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 Object is virtual, image is real. Second point is object distance is equal to image distance. So I am taking here the distance between object to mirror. Object to mirror is the distance between object to mirror is called object. The distance between mirror to object. The distance between mirror to object is called object distance. The distance between mirror to object is called object distance. The distance between mirror to image is called image distance. The distance between mirror to image is called image distance. The distance between object to mirror. The distance between object to mirror is called object distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. So object distance is equal to image distance. And coming to the third one, height of the object is equal to height of the image. Height of the object is equal to height of the image. And coming to the fourth one, so it also shows the lateral inversion. It also shows the lateral inversion. Once again, you can check here. So 3 points are very, very important. What are the points we are discussing now? So object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. Object is taking object, so object is real, image is virtual. Object is virtual, image is real. So object distance is equal to image distance. Object distance is equal to image distance. Object distance is equal to image distance. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. So last one, lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Okay, so if you stand in front of the mirror, and so lift your right hand, it appears in the left side of the image. If you are standing in front of the mirror and lift your right hand, it appears in the left side of the image. If you lift your left hand, it appears in the right side of the image. Okay, so this mirror conversion is called lateral inversion. You can try once. If you are standing in front of the mirror and lift your right hand, it appears in the left side of the image. If you lift your left hand, it appears in the right side of the image. Okay, this mirror image is called lateral inversion. Okay, so you can observe the ambulance written, so the word ambulance written on the vehicle. Okay, so that is a mirror image. If you see in the mirror, it appears proper. Right? Yes, so that is about mirror image. Okay, next one, we are going to the one more. So object is real, image is virtual. Image is real. Object distance is equal to image distance. Height of the object equal to height of the image, and also shows lateral inversion. So I'll ask one question. So it's a practice question. So which letter will not show lateral inversion from A to Z? Capital letters I am saying. Capital letters. So those who know the answer, so I hope you can type it easily. So you can type it, you can message, you can comment. So A to Z. So capital letters A to Z. Which letter? Capital letters. You can take capital letters. Which letter does not show lateral inversion? Which letter does not show lateral inversion? Can anybody say the answer? I am saying wo. I am starting with the answer wo. Which letter does not show lateral inversion? This is the question. So I am starting answer. So my answer is wo. So don't type wo. So other than this letter you can type. Other than this letter, can you type? Anyone? So I'm expecting answer. So I'll wait. I'll give 2 minutes time. I'll give 2 minutes time. So who will type? We'll see. So capital letters I'm taking. Capital letters A to Z. Which letter does not show lateral inversion? Question. Answer. So remaining answer. Okay. Mention in the comment. Let me know the remaining letters. D will show, I hope. D will show lateral inversion. So other than A to Z, other than A to Z, other than O, my. Okay. Very good, Narsi. So congratulations. So you got 10 gold coins. Hi again, sir. I am Twinkle here. Hi, Twinkle. So other than see, this is a question. 2 minutes I'm giving. So 7:45 will start. 7:45 will start next concept. Explanation. Explanation at the rate of 7:45. So can you tell next one? Next letter. Next letter. Can anybody? So question is, which letter does not show lateral inversion? Question, which letter does not show lateral inversion? Or it will shows boss. Chinmay Singh someone. Or it shows lateral inversion, right? We means so here best I will tell our example. Which letter does not means should not show. So why will not show means left or right if you are taking R, so it will appear see like this, right? It is showing only, right? Okay. So U V W, okay, very good. H Chinmay Singh, very good. See, very good. Next, remaining students. Can you type remaining? I'm expecting answers from remaining students also. I'm expecting answer from remaining students also. So I'll be back. So 7:45 I said, no, 7:45 I'll be back. So meanwhile you type the answer. Type the answer, everyone. Okay, come on. Be ready. Capital letters only. I'm saying capital letters only, right? So small letters will not come. What about remaining students? Only few students are attempting. Okay, fine. So we'll go to the next one. So object and image. Okay, so we'll start next one. Spherical mirrors. Coming to spherical mirrors. Spherical mirrors. Spherical mirrors. Spherical mirrors. Spherical mirrors. Mirror, mirror, spherical mirror, 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 spherical mirror. The mirror which is in the form of sphere. So if you are taking the I'm taking the small portion like this. Small portion. If you are taking small portion, that is called curvature. If you are taking small portion, that is called curvature. If you are taking small portion, that is called curvature. Depending on reflection of light, depending on reflection of light. So mirrors are divided into two types. One is concave mirror and the one is convex mirror. Concave mirror, convex mirror, oh, concave mirror, convex mirror. So when the reflection of light takes place inward, is called concave mirror. Concave mirror. A reflection of light takes place inward is known as concave mirror. Concave mirror. Concave mirror. So concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Converging mirror. Concave mirror is also known as converging mirror. Concave mirror. Converging mirror. Concave mirror. Converging mirror. Mirror, mirror. Concave mirror, converging mirror, concave mirror, converging mirror, convex mirror, diverging mirror, convex mirror, diverging mirror, diverging mirror, diverging mirror, diverging mirror, diverging mirror. I am taking here pole focus, center of curvature. Concave mirror is known as converging mirror. Converging mirror. Come on. Converging mirror. Convex mirror is known as. Convex mirror is known as. Do you understanding? Are you understanding? Convex mirror is known as diverging mirror. Diverging mirror. Why we are saying concave mirror is converging mirror? Why we are saying? What is the reason behind of it? Why? Why concave mirror is known as converging mirror? Concave mirror is known as converging mirror. Why we are calling? Why we are calling? Because whenever the light rays are incident on it, after reflection, light rays will move towards the principal axis. After reflection, light rays will move towards the principal axis. When the light rays are incidenting on it, after reflection, light rays will move towards the principal axis. That's why it is called converging mirror. That's why it is called converging mirror. Why we are saying convex mirror is known as diverging mirror? Why we are saying convex mirror is diverging mirror? Convex mirror is diverging mirror because whenever the light rays are incidenting on it, whenever the light rays are incidenting on it, whenever the light rays incidenting on it, whenever the light rays incidenting on it, those are, those are, those are moving away from the principal axis. Those are moving away from the principal axis. After reflection, light rays are moving away from the principal axis. Here, after incidenting, light rays will move towards the principal axis. After reflection, light rays are moving towards the principal axis. That's why it is called converging mirror. After reflection, light rays are moving away from the principal axis. That's why it is called diverging mirror. Convex mirror, converging, concave mirror, converging mirror, convex mirror, concave mirror. Concave mirror, converging mirror, convex mirror, diverging mirror, diverging mirror, diverging mirror. So concave mirror is also known as converging mirror. So concave concave mirror is known as converging mirror. Convex mirror is known as diverging mirror. Diverging mirror, diverging mirror. Okay, so next we are going to the terms related to spherical mirror. Terms related to spherical mirror. Terms related to spherical mirror. Spherical mirror, spherical mirror, terms related to spherical mirror, spherical mirror, spherical mirror. Terms related to spherical mirror. Come on, everybody listen here. Listen here. Listen here. Everybody listen here. Very, 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 very important. 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 Convex. Concave mirror is known as converging mirror. Convex mirror is known as diverging mirror. Yes or no? Now you are going to that. So terms related to spherical mirror. Terms related to spherical mirror. Terms related to spherical mirror. Okay. Come on, everybody. So we'll discuss this point. After that, we'll take break. So join at 9 p.m. 9 p.m. So today 9 p.m. you can join at 9 p.m. So I'm taking this the pole. So actually this is the curvature. This is the sphere. This is the center of the sphere. Center of the imaginary sphere. Center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part. In which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. Center of the imaginary sphere. Center of the imaginary sphere in which center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. Center of curvature. Center of the imaginary sphere in which mirror is a part is called center of curvature. So the midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The line joining of center curvature and pole is called. The line joining of center curvature and pole is called. The line joining of center curvature and pole is called principal axis. Principal axis. Principal axis. Principal axis. Principal axis. Principal axis. Come on, everybody. Principal axis. The line joining of central curvature pole is called. The line joining of central curvature pole is called principal axis. Principal axis. The line joining of central curvature pole is called principal axis. Principal axis. Principal axis. Principal axis. Okay, so I'm taking here the line joining of center curvature pole is called principal axis. Principal axis. So pole, third one is principal axis. Principal axis. Principal axis. Principal axis. And coming to the fourth one, the distance between center curvature to pole is called. The distance between center curvature to pole is called radius of curvature. Radius of curvature. The distance between center curvature to pole is called radius of curvature. Radius of curvature. The distance between center curvature to pole is called. The distance between center curvature to pole is called distance between radius of curvature. Radius of curvature. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet. After reflection, all light rays will meet one point on the principal axis called focus. The distance between focus to pole. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Focal length. Focal length. Focal length. So once again, all these points we'll discuss. So the center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The line joining of center curvature and pole is called principal axis. The line joining of center curvature and pole is called principal axis. The line joining of center curvature and pole is called principal axis. Principal axis. And so the distance between center curvature and pole is called radius of curvature. After reflection, all light rays will meet at one point on the principal axis, that is called principal focus. And the distance between focus to pole is called focal length. And the width of the mirror is called aperture. 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 Pole, center of curvature, pole, focus, principal, axis, radius of curvature, focal length, focus, focus, aperture, focus, and aperture, focus, and aperture, center of curvature, radius of curvature, focal length, focus, focus, aperture, aperture, principal axis, principal axis, principal axis, principal axis. So I hope it is very clear to you all. So till now we discussed about terms related to spherical mirror. Terms related to spherical mirror. So remaining points we'll discuss in the next class. So 9 o'clock, today 9 p.m. You can join to the class. Again we'll discuss today 9 p.m. Today 9 p.m. sharp. Today 9 p.m. So you can join at 9 p.m. So to the physics class. So we'll discuss more about this point. So if you like this video, please do like, share, and subscribe to Student the Brand. So if you like this content, you can subscribe my channel and you can share to your friends. So spread one word regarding Student the Brand. Everyone will get to know. Okay. So until then, see you. Namaste. Thank you.